What if I told you the biggest solar flare of the year just erupted, and it's only the beginning? Most people think space weather is boring, until it fries your GPS, knocks out your radio, or lights up the sky with auroras hundreds of miles from the poles. This isn't sci-fi. This is what's happening right now. Solar flares aren't just bright bursts. They're Earth-shaking events that can silently disrupt everything from planes to power grids. Most reports say, don't worry, this flare wasn't Earth-facing. But the real story is that the sunspot that launched it, AR-4087, is now turning to face us. This X2.7 flare isn't just the strongest of the year. It's part of a chain reaction that could get worse in days. And scientists are watching it like hawks. Here's what you've probably heard. The sun had a solar flare. It wasn't aimed at Earth. Nothing to worry about. Well, that's not the full picture. Because this isn't just one flare, it's the start of something bigger. And the sunspot responsible? It's rotating toward Earth right now. On May 14th, the sun released an X2.7 class flare, its most powerful of the year. Most people stopped reading after not Earth-facing. But here's where it gets interesting. This sunspot's aiming mechanism, if you will, is turning. And it's still firing. So in this video, we're going to break down what just happened, simply and visually show what could happen next, and give you the tools to understand why this matters, whether you're into tech, travel, or just sky watching. Hey tech enthusiasts, welcome to NotSoTechie, where we decode big science stories without frying your brain. If you love staying ahead of the curve on real space events, hit like, subscribe, and stick around. Because what's coming next, it's bigger than just one flare. It wasn't just a solar flare, it was an X2.7 monster. X-class is the highest level. Think of it like a Richter scale for the sun, and this one was 2.7 times beyond X1. To put that into perspective, M-class flares already mess with radio. X-class flares? They bend the rules. This one caused radio blackouts over Europe, Asia, and the Middle East. Even North and South America saw shortwave disruptions. You know it's serious when pilots, sailors, and ham radio operators all stop hearing each other. But that's not the wildest part. The region that fired this thing, AR-4087, is just getting warmed up. Literally, TenFlare and R3-level storm tech took a hit. Alongside the flare, we got a 10 centimeters radio burst, aka a TenFlare, which basically creates static loud enough to confuse GPS, radar, and satellite comms. That's why the Space Weather Prediction Center tagged it as an R3 event, strong enough to fry high-frequency communication for hours. If you noticed weird GPS lags or comms blackouts, yep, this flare could be why. And here's the kicker. These effects happen almost instantly because it's radiation traveling at light speed. No time to duck. But if the radiation moves fast, imagine what happens when slower, heavier stuff comes flying toward us. A CME was launched, but missed us this time. Think of a CME, coronal mass ejection, like a solar sneeze. Billions of tons of charged particles launched into space. Luckily, AR-4087 was near the eastern limb of the sun when it erupted. That means the CME missed Earth. But here's the catch. As AR-4087 rotates, future CMEs might not miss. And that's why scientists are on alert. A direct hit could trigger geomagnetic storms, frying satellites, disrupting grids, and possibly making auroras visible far from the poles. And guess what? This region didn't stop at one flare. It's been on a rampage. This sunspot is the overachiever of Solar Cycle 25. AR-4087 also gave us M5.4, M1.2, M5.3, M7.74, M7.5, and an M.46, all in a single day. It's like it had too much coffee and decided to start a fireworks show. Even more, a different sunspot on the opposite side of the sun released an X1.2 flare. So the sun didn't just wake up. It's practically stretching both arms and slapping space. But why is all this happening now? What's changed? We're at solar maximum, and this is just the beginning. Every 11 years, the sun goes through a cycle, and we're right near the peak, called the solar maximum. 2024 officially kicked it off, and 2025 is shaping up to be the main event. The X2.7 flare is already the strongest of 2025, the 15th most powerful of the cycle, and we're only halfway through the year. Back in October 2024, we saw an X9.0 flare. That's nuclear-level solar weather. So this X2.7 could be a trailer for what's coming next. But you might be wondering, why are solar flares and CMEs more common now? What's special about the solar maximum? The answer lies in the sun's magnetic field. During solar maximum, the sun's magnetic field lines become twisted and tangled. This creates more sunspots, which are areas of intense magnetic activity, and increases the likelihood of solar flares and CMEs. It's like winding up a rubber band. Eventually it snaps, releasing energy. According to NASA, the magnetic field flips completely, with the north and south poles swapping places. But what happens after solar maximum? Does the sun just go quiet again? Yes, after reaching its peak, solar activity gradually declines over the next few years, eventually reaching a solar minimum. Sunspots become less frequent, and major flares and CMEs are less common. However, even during solar minimum, the sun can still produce significant events, so it's important to maintain ongoing monitoring. So here's where we stand. A powerful flare just erupted. The sunspot responsible is now rotating toward Earth, and we're in the most active part of the sun cycle. What starts with radio blackouts could end with global auroras, or worse, tech chaos. Speaking of auroras, you might be wondering how these solar events actually create those beautiful lights in the sky. When a CME reaches Earth, the charged particles interact with our planet's magnetic field, being funneled towards the poles. These particles then collide with atoms and molecules in the atmosphere, exciting them and causing them to release energy in the form of light. That's what gives auroras their vibrant colors, ranging from green and pink to red and violet. The stronger the geomagnetic storm, the further away from the poles these auroras can be seen. But don't panic, get informed. Space agencies are tracking it. We're reporting it. And you're now in the know. So if you want science without the fluff, with real-time updates on space weather, earth-shaking discoveries, and how it all connects to your daily life, hit that like button, subscribe, and share this video with someone who still thinks the sun is just a yellow ball in the sky. We've only scratched the surface. The sun's not done yet. Until next time, stay curious, stay grounded, and don't forget to look up.